Hello everyone and welcome. My name is Rečko Prokic. This is new project on the education ecosystem platform, and our topic in this project will be to solve 25 programming problems for the C jobs interviews. So we have 25 problems and we will start from these five first. But I want to start from the problem number 2 because it's a really nice problem. You can see the source code here. It's just a main function, nothing hard. Okay, so the goal is to break the password protection code. Okay, we have our main function, then we have variable flag equal to 0, then we have one array in our memory with 10 elements, and the type of array is char, so for the characters. Then we're going to call the memset function, so it will set the value for each element in our array. The first argument is the starting point, then which value to insert and on how many bytes in memory. So we will pass the size of array, it will be 10 bytes, and put 0 for each element starting from here. Okay, next we're going to call a string copy function, so it will just copy data bytes from one location in memory to another one location in memory. So it will, in our example, it will copy the data, the bytes from the first command line argument, and it will copy that into our array. And now this is very important because we are inside of our main function. This array will be on the stack. Okay, and then we have one if conditional statement. We will compare the password string to our value inside of our array in memory. So we will compare these two strings. And if they're equal, the string compare will return 0. So if the string compare returns 0, then set the flag to 1. In other words, you entered a good password. But if they are not equal, the flag will be 0. And then check the value of the flag. If it is 1, then print the password correct. If it's 0, print incorrect password. Okay, so this is a way. This is a way to compile our problem. So it has a lot of arguments, so it's not a problem. Those are just some flags for the compiler because I want to run this program later in the GDB. Just write everything on the same way. Okay, compilation is good. Let me clear the screen. I will run the program. I will enter ASDFGH, and that's incorrect, you know that. But if I enter something like password, I get password correct. Okay, but everything is working right now. So where is the problem? Well, the problem is here. I will type something like this. So this should be incorrect password, but I got password correct. I will put less of these A's. Again, password correct. You can notice here that I also got segmentational fault, core dump error. So something is really bad with the memory. So right now I will explain you why that happened, and I will tell you which function you can use to avoid that error, and I will show you with using of GDB debugger. I will show you what really happened in memory. So first I want to tell you why we cracked our password. Okay, so the string copy function is bad function. So it will copy the bytes from uh, one location in memory to another location in memory, but it will not check the size of the location in memory. So I will take the bytes, string copy will take the bytes from the memory, from some place in the memory, and it will store that on some other place in memory, but it will not check the size of that place in memory. So in our example, we have our array with 10 elements, that will be 10 bytes in memory, but we have copied one really big value, much bigger than 10 bytes, inside of that array, and we got an overflow. So the spill of values after the array. So it shouldn't happen. Because of that overflow, we got some values inside of our variable flag. And flag was not 0 anymore, it became 1. So it became a positive value because it has some values that are uh, not 0. So if conditional statement, if you have 0, it will be false. Every other value will be true. So because of that overflow here, we got some value inside of our flag that was not 0, and this was true. It doesn't matter which value we get here. It really just matters to be some value that's not 0. And because of that, we cracked our password. Okay, I will run right now in the GDB. Okay, so here I can check my variables, go through each step of my program. So I will set the breakpoint at the main. So I will run the program and it will stop at the beginning of the main. So you can see we have one breakpoint. Now I will type run, and it will run our program. Now you can see that we are at the breakpoint. In the main, we have two arguments. First argument is the program name, and the second argument is this. And then this is the next line to execute this statement here. I can type L for the list, and I will get my source code list here. Now I want to type N for, this is just short for the next. So this is the next statement to execute. I will type N again. Now I will stop. So this is the next statement to execute. I want to see a couple of things right now. First thing, I want to print, so this is a command for printing. I want to print the value of the flag. It's 0. Okay. Now I want to print the address of the flag. This is important. I will not read this FFF. This is our CFA0. So this is the address of our variable flag inside of our memory. And now I'm going to print the address of the first element of our array. So you can see that is CFD6. Okay. One thing about the stack, you can see here. The stack will grow from the high address to the lower addresses. So somewhere here, because you can see the address of the flag is bigger than the address of our first element in array. So the flag will be like something somewhere here, and our array will be somewhere lower here. Okay, right now I want to show you how to examine the memory location. So I want to print the 20 bytes in hexadecimal starting from this address here. And you can see here, so this is the first element of our array. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, because our variable flag is at place A0, here is the A6, A5, 4, 3, 2, 1, 0. So here is our variable flag, the beginning of our variable flag. And you can see that we have 1, 2, 3, 4 zeros because each of these digits represents 1 byte. And the integer has size of 4 bytes. Okay, right now, what will happen? Well, we will call this function string copy, and it will copy this big string, and each character is 1 byte. It will copy that in memory starting from here. And we will copy each byte, and we are going to overflow the value of our variable flag. I'm going to execute the string copy. If I again examine the memory locations, you will see what I'm talking about. So you can see in the hexadecimal 61, so it just stands for the A. I will print that not as a hexadecimal, I will print that as a character. So you can see a lot of A's inside of our memory on the stack. But our array will end here or here, I'm not sure. After that, it's all other locations on the stack. So we created an overflow and we changed the value of our variable flag. Right now I will print the flag and you will see one really big number here. Okay, but if I print that number in hexadecimal format, you will see 61616161. So those are the values from here in the hexadecimal format. And because of that, we don't have 0 anymore. We will have some value that's not 0, and we will execute this if condition, and we have password cracked. So it's really a nice thing using GDB to find the errors, to see how memory is working and stuff like that. So if you're interested in project around these topics, maybe reverse engineering, buffer overflows, how to crack the programs, we can create a project specifically for that, and leave that in comments if you want, and we will see in the next part where will we solve these first, third one, fourth one, and the fifth one problem. So see you in the next part. Yeah, I just forgot to mention and to show you how to create a better solution for this problem number 2. So again, I'm gonna open the source code. So instead of using a string copy, I will use str and copy, and then here I'm gonna put size of. So what the string and copy will do? Well, it will copy bytes from here, from the source, into destination, but you will also specify how many bytes you're going to copy. So I will put the size of our array and nothing bigger than that. So when you're using str and copy, you will provide the source, destination, and the third argument will be the size, how many bytes you're going to copy. And it's really good because when you're using that function, you cannot have overflow. Now I'm gonna compile again. I will try to run this. Okay, it's incorrect. But if I put something really big, we get incorrect password. I can run again in the GDB with a really big password. I will put the break into the main. I will run. Okay, I will go to the next. Now I'm going to print the flag. you can see the flag is 0. Now we have to examine for the 20 bytes in hexadecimal, starting on the address of the array. So it's just an address of the first element, and you can see the zeros. So we are empty our array on the stack, and you can see here again a flag probably. Yeah, it's CFD0. So it's the 6, 5, 4, 3, 2, 1. Probably somewhere here is the starting of our flag variable, and here is our array. Now when I execute the string and copy, I will again, it's our so this is the first element of our array, and you can see that we copied only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So only 10 bytes are filled with our data. The rest of that, it's like it doesn't exist. So you can see here the zeros for the flag, and our variable is still 0. So we will get incorrect password, and here is the end of our program. So that's it. That's the way to solve this problem. So use, instead of using string copy, use strn copy. So you can see on the man pages, so string copy, strn copy, and you can see the description, returning values, and stuff like that. So read the man pages. They are really good source of information. Welcome back, everyone. So it's time to continue working on our problems. So right now I'm going to open problem number 1. So we need to detect the hidden problem with code in this example. So we have one main function, and you can see one array called buff with 10 elements, type of char. Then we're gonna empty this array, so fill it with zeros. You already saw that in previous example. And then we're going to call the function gets. It will just read data from the keyboard, from the standard input, and then it will store that into the buffer. The problem is with that function gets, because it will read data from the keyboard until you press enter or new line character, and then it will stop, and it will store all the data inside of this location in memory pointed by buff. Where is the problem? Well, the buff only have space for the 10 elements, and if you enter more than that, you will get an overflow. We are going to compile this. Now you got a warning from the GCC to not use gets and to use fgets instead. If we're going to run this, and then I will enter hello, and you can see the buffer entered is hello. But if I enter something like this, we got a stack overflow. So this is just a notification from the compiler, stack smashing detected, and we have a core dump. Okay, so how to fix that? Well, you should use fgets instead. Now we are going to use fgets. You will have 3 arguments. First one will be where to store the data. So we are going to store data in the memory pointed by buff, so in our array. Then how much space we have? Well, it's the size of buff, and then read from the standard input stdin. Now it will work. I will type really big character, and you can see we don't have overflow anymore, and everything is working good. Okay, now I'm gonna open problem number 3. So, is there any problem with the following code? Will it compile? So we have main function, it's void type, and we are allocating memory from the heap. We are allocating memory for the 10 bytes. Here we are going just to check if everything was good. So if something is bad, then malloc failed and return. Else do some processing, and at the end free your memory. It's good. What we can change here? Well, we can change uh, type of the main function. So do not use void type for the main. Instead, use integer main. Why? Because when you're returning values, you don't have any return code when you're using void main. You just type return and that's all. But when you have integer type for the main, you're returning with some value. Now, if you return, for example, with 1, it will we will know that it has some errors inside. And if you return with 0, everything is okay. Here also you can put -1, it will be the same, so something bad happened. Everything that is not 0 is bad. Why is this useful? Well, if you have multiple programs or scripts or whatever, you can inspect the return code from the program, and you can know if something was good or if some error happened while you executed that program. So use the main because you can pass the information at the end if everything was good or you had some errors. So use the integer main all the time. Now we have problem number 4. Will the following code result in memory leak? So again, we are allocating the 10 bytes from the heap. We are checking if error happened. Again, here we have void. I will change that to integer, and I will pass here 1 because error happened. If everything is good, I will pass the 0. Okay, so yes, we have a leak. Why? Well, because we allocated 10 bytes on the heap and we didn't free that memory. So, how to check for the memory leaks? Well, you can use something like this. Now, use a tool called valgrind and run your program. Now, valgrind is used for checking memory errors. Now, you can see here heap summary. So, in use it exit 10 bytes in one block. So, we have one block because we allocated memory only once. Only once we called malloc. And you can see these 10 bytes from this call here. So, we have 10 bytes in one block and a leak summary at the end. We definitely lost 10 bytes in one blocks. So you have memory leaks, it's bad. You can change that. So when your program ends, you just have to free. When you don't need that part of the heap memory anymore, just free that. So right now I'm gonna compile it. Oh, I'm sorry. Yeah, and I'll run that with valgrind. And you can see total heap usage 1 allocs, 1 freeze, and 10 bytes allocated. All heap blocks were freed, no leaks are possible. So now everything is good. You can use valgrind in the bigger projects. It's really nice tool. Next is the problem number 5. Okay, so the question here is why this program sec faults or crashes. So we have a crash here. Again, we are allocating 10 bytes on the heap. We are checking if everything was good. Uh, we have to return -1 if something was bad. Okay, so we are going to copy the argument from the command line into our memory in the heap. And then we are going to start to each element, and we're going to check if that element is 0. So this is the mark for the end, and if you find else, just increment, and if you find set, then break out of that loop and print information string contains set, and then at the end you will free that memory. Okay, so it will just search for this symbol z in our method string, and it will crash. Now we're gonna see why it will crash. Okay, so I'm gonna put something like zebra, and string contains z, and it didn't crash. Okay, so I can put freeze, and we have core dumped, and we have a message invalid pointer. So what happened here? Well, we have done something that we shouldn't do. So we changed this value of this pointer. So this pointer should always point to the beginning of the block on heap. So this is the allocation. If malloc is good, it will return the pointer to the start of that block. So you can see that here, man malloc. So you can see the description and return value. The malloc and the calloc will return the pointer to the allocated memory. So when you change that pointer, when you change the value of that pointer, when you call free, you will not free the whole block. So you shouldn't do that. Instead, you can, for example, have temporary pointer. I'm sorry. Oh, yeah, temporary pointer. Then you can here say temp is equal to ptr, and here you will use temp. You will use temp instead. Also here use temp, but at the end you are going to use the ptr because it points to the whole block or the memory on the heap. So I will compile that again. I will run it. I will try freeze, string contains z. I will try zebra. I will try something else that doesn't contain z. Okay, so now everything is working. So those are the first 5 problems. See you in the next video. Welcome back, everyone. It's time to continue our work on the interview problems for the C language for the job interviews. So we covered the first 5 problems. Now it's time to cover next 10 problems. In total, we have 25 problems. So let's start with problem number 6. Let's see. So you can see here is the question. So function registered with @exit is not being called. Why? So you can use function called @exit to register some function. In this case, function is func, to be invoked and started at exit from the program, so at our termination. But in this case, it will not be started. Why? We're gonna see very soon. So let's compile this program just to show you. And you can see on the output we don't get our function func. Why? Well, you can read the man pages for both of these functions. So at exit will register a function to be called at normal process termination. But also you can see here that this function exit it is the same like the exit, the classic exit function, but does not call any function registers with at exit or on exit. So it will not call any of these functions that are registered with at exit or on exit. So it's the difference between this function here and this function here, and that's the reason why we didn't get our function func. But if we used something like this, then we are going to get our function at the exit. Yes, I think I should put stdlib include stdlib.h, and I like to put a space here. Okay, compile again, clear. Now we get our cleanup function. Okay, let's jump on the problem number 7. Let's see. Okay, so what's the output of this code here? So we have one string called Linux, and now we are going to print the two characters with one printf and another one printf. Now it's just the matter of the priority of the operators. So this operator here and this operator here, they have the same priority. So this line will print L, the first character, then it will increment the PTR pointer, and this line here will print I character, because they have the same priority here. And we can go from the right side to the left, but this is the post increment operator. So you have two type of operators. You have for example I++, which is post increment, and ++I, which is pre-increment. So this will use I for the current statement, and when you finish that statement it will increment I, but this pre-increment, this operator ++ will first increment I and then use it in the current statement. So because of that, we are going to use the current value of the PTR. We will display that character on that position. Then we're going to increment, and on the next line we will get character I printed on the screen. We're going to see that now. Okay, so yeah, you can see L, I. Okay, so enough about problem number 7. Let's go to problem number 8. Let's see. So the question is, this code crashes. Why this code crashes? So you have char ptr Linux, and then you're modifying the first character to T, and then you're printing your string, and yes, it will crash. Why? You're gonna see in the moment. So yeah, we got a segmentation fault, core dumped here. Why? Well, this segment of the code is on the read-only memory, and you cannot change that code. And we are trying to change any of these. You can change the pointer to point to some other character, but you cannot change the value inside of that memory location. So here you are changing the value of that location, and because of that it's a read-only memory region. this will produce error. This will crash your program. So you should not use this. Now it will work, and you can see our string. Okay, so let's go on the problem number 9. So write the program to change its own name when run. Okay, so you know that arguments for your program are in RGB, and RGC just stores the how many arguments you have. At place RGB0, there will be your program name, and I will read the first command line argument, which is the RGB1, because RGB0 is the program name, and I will copy that first command line argument into uh, name of our program. Okay, so, and then I put some sleep here, but we don't need that right now. So GCC program number 9. Yep, I got some error here. Yeah, I didn't provide a new name, so I should always put a new. I should put argument always, and you can see here the program name before change was PR9, and the program name changed. We have new name right at the moment, because the first argument in the command line is copied into our name of our program. So here is the actually copy part of first command line argument is going to be our program name. So, and here is the line where we are making the actual change of that. Okay, so let's continue. Program number 10. Is there any problem with this code here? Okay, so we have a main. We are creating one variable a inside of the main, which is equal to 10. Then we have one pointer to the integer type, and we are calling function increment a. That function will return integer to us, and it will just read the argument. It will increment that argument, and it will return that inside of that value inside of our main function. And you can see the incremented value is equal to, and then the display of that. Okay, so right now I will try to compile this. I don't know what will happen. Okay, I got warnings, and again the most famous crash inside of C program is segmentation fault. So we got that crash again. Why? Well, this variable I here is on the stack, and this stack frame will exist only while we are inside of increment function. When we are done with that increment function, that stack frame will be deleted, and we will lost our variable a, but we are returning the address of a, so you cannot do that. What you can do here instead, well, you may use something like this integer a pointer, pointer a, and it will be, so allocate a memory from heap, and then something like this is okay. And now this will work. Yeah, I need to include my std.h. And you can see incremented value is equal to 11. Okay, What I forgot to do here is to free my memory. We spoke about that. Free A, compile that again. I'm sorry, it's a free val, not A. Val, okay. Everything is good. And everything is good now. Let's go to the problem number 11. Let's see. What will be the output of this program? Okay, so the arguments are going from the left to the right, but the actual usage of that arguments will go from the right to the left. So compiler will do from the right to the left. Normally you're reading from the left to the right, but for the compiler it will be C is equal C times 2, which is 60. Then B is equal B times 2, which will be 40, so 40, 60. And A will be plus B plus C, which will be right now 60 plus 40 plus 10, which will be 110, 40 and 60. Because the actual implementation will go from the right to the left. Let's compile that. And you can see that's the numbers we get. Let's go to the problem number 12. Okay, so what is the output of this code here? So we have one directive here, the preprocessor. Okay, then we're calling printf the square 4. There we are going to get the 16, but here we are creating one variable inside of the main, which is equal to 3. And then we're going to print the... So the question is, what will we get here? Here we are getting 16, but we're sending the pre-order increment plus plus x. So here will be plus plus x times plus plus x. Because this is the pre-order increment, you will increment this value twice. Here you will increment, and here you're gonna increment. It will be like something like... I'm sorry. It will be something like plus 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 x times plus plus x. So you're going to increment the x value twice, and it will be 5, and 5 times 5 will be 25. We're gonna see that right now. We get 25. Okay, we got 16 from the 4, but we got 25 because you increment twice your x value. Okay, let's go to the problem number 13. What's the output on the 32-bit architecture? We got a variable, which is -2. Then we're going to shift bits 3 times in the right side, and the question is what we're gonna get. So it will just shift the bits of your current value, and -2 is -1 0, I think, in binary, and when you do the shifts you will get a -1 at the end. So you're gonna see now. Yeah, we got a -1. Why is that the case? Well, just a second. So the -2 is in 1 1 1 1 1 1 0, something like this in the binary, and when you shift that for 3 times, you will get, at the end you will get maybe 0 somewhere, but at the end you will get once, and because of that we will get a -1 value. So that was the case here. Problem number 14. So we're going just to check if the string user enter on the terminal is palindrome or not. So this is my function to check for the palindrome. I define max characters to read to be 10, And then you can see here one array next plus 2. Why 2? Well, one place will be for the new line character and other place will be for null byte. And then we're going to read from the keyboard, and then I'm calling the function is palindrome. I will have one place to go from the back, and I will go from the first position. You can see here the debug info start from, and I will do that while I is less than back, so while I'm not in the middle. So they will start from the two different ends, one from the left end, and the back will be from the right end. And when they're equal, I will stop. If they're equal, okay, do nothing, just continue. But if they're not equal, just print the string is not palindrome and return. Of course, increment I and decrement back. And in the end, if you come over here, the string is palindrome and display that and return. Okay, so GCC problem 14. Okay, so I'm gonna run the problem 14 right now. And you can see the start at A and G, and they're going to the middle, and then they're going to stop. And this string is not the palindrome. I'm gonna start again. ASD DSA string is palindrome. Okay, let's see problem number 15. So swap two numbers without using a temporary variables. It's a really the classic one problem. So we have two variables with their value, print them before the before the swapping values, and then just do the basic math, incrementing and decrementing. And this is the actual algorithm to do the swapping of the values, and at the end print that values on the screen. Now, yeah, I created some file here again. Oh, never mind. Copy problem number 15. Okay, run that. 10 and the 5, and you can see here before and after the swap. I can 10 and minus 5, for example, and we will get 10 minus 5 minus 5, 10. Okay, so that's all for this part. See you in the next video where we're going to finish our last 10 questions there. Those questions are a little bit harder with linked lists and trees and some different algorithms, some number theory and stuff like that. So see you in the next video. It will be fun. Hi everyone and welcome back. This is part number 5 on our project, and right now it's time to solve next 5 problems. They are a little harder than previous ones, and let's take a look on the problem 16 that C. So the question is, what is a static function in C? And you can see that I'm calling two functions, and they are not uh, defined inside of this program here. They are inside of func.c, and you can see one function is type void, the other one is also type void, but say hello protected is static function. So static function is just a function that static has a scope that's limited to its object file. It means that you can call this say hello protected only from this func.c object file when you compile that file. So I cannot call function say hello protected from my program 16.c object file when it's compiled. Now you're gonna see the error I will get because of because of that. And you can see undefined reference to say hello protected. So you cannot call that function. But if I, for example, delete here the static part, then I can run, ignore warnings right now, and I will get the messages. But if the function is declared as static, you can only make function calls to that function from its object file. Okay, let's go on the next problem, problem number 17. Let's see. So our task is to write a program to remove duplicates from a sorted linked list. So very important here, always pay attention to that details, little details. So linked list will be sorted. Okay. So this is our data structure. You should be already familiar with that. This is a function for removing duplicates. We will see that later. Function just to display all nodes from linked list. So very basic function. And in main, I will read numbers from command line arguments, and I will, for each number, I will create a different node. So here's the process for that. This will be converted from char to integer. Then I will allocate the space and I will fill my structure. If my list is empty, I will, this is the head of my list. Otherwise, just put that number on the end of our linked list. Then I will print linked list before duplicate removal, and I will print a linked list after the duplicate removal. Okay, so how to actually remove duplicates? Well, I will have two pointers, next, and a pointer for the current location of for the current node, and then I will start from the first element, from the head. I will traverse the linked list until the end, and if I find that my current node is equal to the next node, then I will remove that next node. And if that's not the case, I will increment my current pointer. So that's really basic algorithm for dealing with removing the duplicates from the linked list. But we already know that numbers will be sorted inside of that link list. Okay, so if they're not sorted, the algorithm would be very different. So right now I'm gonna compile this. I'm gonna run that. I will provide arguments 1, 2, 2, 2, 3, 3, 3, 3, 4, 4, 5, 5, 5, 5. A lot of 5s I will put here. And you can see, so this is the linked list before duplicates removal, and this is our linked list after the duplicates removal. So very easy, piece of a cake. Oh. Let's see problem number 18. Okay, so find the middle element of the linked list in one pass. So here is the detail in that on the end. In one pass, find the middle element of our linked list. Again, our data structure. Again, I will read my data from the command line arguments. It's easier for me to do that way. The process is still the same, so convert the character to integer, then allocate the space, fill the data structure. If your head is empty, that means that this is your first element, this is your head. Otherwise, put that element at the end of linked list, and then find the middle element in one pass. Okay, so I will use two pointers, temp, and the starting point will be from the head, and the middle will also have the same starting point as temp pointer, but only difference is that I will increment temp pointer twice, but middle pointer I will increment only once. And right now you will see what we're going to get here. GCC problem 18.c. 18, and I can enter something like this, and I will get a message middle element is 3. I can enter more numbers. Middle element is 6. But if you enter, for example, 10 elements, now you can see one thing. Uh, Middle element is 6. Okay, so um, we entered the even number of uh, different elements, and because of that the middle will be 5 or 6. There's no really mistake there. Our algorithm will throw the 6 on the output, so that's not a mistake. Everything is okay. Let's go on the next problem. Okay, so reverse linked list. So that's our next problem here. Again, everything is the same. We have our node, how to print the list, how to read from the command line arguments. Then I will print the list, I will reverse, and I will print list again. And how to reverse that? Well, this is the technique of 3 pointers for the previous element, for the current element, and for the next element. Now you have a couple of different statements that are really important here. So first we're going to store the next address to the next element. Then we will reverse the current node pointer, and then at the end we will move the pointer one position ahead. So it's really a basic one algorithm. You just really take care about order of these statements, because you can really easy make a mistake here, and you can have some kind of weird bugs there. But it's just 4 statements inside of one while loop, and inside of that while loop we will go from the first element to the last element of our linked list. You can see how that looks like. And I'm gonna enter something like this, and we get our linked list reversed. So it's very easy, really. Now we're gonna take a look at problem number 20. Now, here is the problem with binary search trees. So write code for the in-order traversal of binary search tree. Okay, this is our data structure. It's not the same as with the linked list. We have 2 pointers here for the left and for the right side of one node. Now, so if you don't know theory about binary search trees, then look on the internet for that. This is a function for just displaying a simple output to the user. So it's really simple. Then we have a function for inserting element inside of our binary search tree. Insertion is really basic thing for the binary search trees. So first we will check if we have a root node. So if our tree is empty, then we have a root node. Then we will always determine where to go, to the left subtree or to right subtree. So, and at the end we will assign the actual value. We will add our new node to our tree. So if you have a node on the left side, there will be elements that are smaller than that node, and on the right side there will be elements that are bigger than that node. Okay, so you should always take care about that. So that's a property of binary search tree. And then we have in order traversal. It's really really simple. So first we are checking if the node is not null. If the node is null, then nothing happens. So function will just return. And first we are going into the left subtree, and then we are displaying data, and then we're going to the right subtree. So it will first display the left subtree of the node, then it will display the node, and then it will display the right subtree of your binary search tree. Now I'm gonna compile this program. You're gonna see that an example. I'm gonna run this program, and now you should choose one of the options. So insert element or in order traversal or exit. I can try in order traversal, and I didn't get data on my output on my screen because the tree is empty. I can insert some element like 3, then 2, then 1, then for example 5. And right now when I type in order traversal, I will get 1, 2, 3, 5. Why? Well, we first entered number 3, so the 3 is our root node. It's the root of our binary search tree. Then I entered a node with data 2. It will be on the left side from our tree, from our root node. Then I entered 1. It will be on the left side from our node 2. And then I've entered 5. It will be on the right side of my root node. But when you go into in order traversal, it will display them in this order here. There's also a pre-order traversal or post-order traversal. There are different type of algorithms. You can find them on the. So I'll exit right now. You can find them on the internet, because in the next problems we are going to solve different kind of problems. We are not going to work with traversals of binary search trees, but if you're interested, you can try to implement, for example, pre-order traversal. So read what is the pre-order traversal and then try to implement as a fourth option in this program here. So see you in the next video. Bye. Okay, so this is our last part in this project. So we have 5 more problems to solve. So let's jump on the problem number 21.c. So here is our task to calculate the depth of the binary search tree. So this is our data structure, our node representation. Here is our root node, how to insert the new element. So this will be the pointer to the root node and then the value to insert. And then here we have a function to get the depth of the binary search tree or to get the height of the binary search tree. It's the same. If the tree is empty, so a root node will be equal to null, then return 0. And what is the main idea in this algorithm? Well, we will go left from the root node and right from the root node, and we will calculate each node from on the left side and on the right side. And when we finish, here is the actual recursive way to do that. And when we finish that, if we have on the left side more nodes than on the right side, then we will return that number of nodes from the left side, or else we will return the number of the nodes on the right side. So it's very easy, and we are going to read the arguments from the command line. We will read the data from the command line for the nodes. Let me compile it. Okay. The depth of the binary search tree is 0 because I didn't provide any arguments for our tree. Now I can enter something like 42035 and the depth of the binary search tree is 3. I can enter something like 7. Now it should be 5. Yeah, right now it's 5. Okay, let's jump on the problem number 22. Okay, so sort array with quick sort and read numbers for array from the standard input. Okay, so here is our main function. I will read the n number of elements, number of different elements for array. Then I will read the values for array, and then I will call the function quicksort, and then I will print the sorted array. So quicksort is just a function for the algorithm for quicksort is divide and conquer algorithm, and it's really efficient on the big data sets. But here is the our quicksort function. And then we will have two parts of our array, left side and the right side from the pivot element. What is important in quicksort? Well, the most important thing probably is to carefully choose your pivot element, because it could increase or decrease performance of this algorithm. And then if we find some element that is smaller than our pivot, then we're going to increment the index of the smaller element, and we are going to perform the swap actually. So, and here is the function for the swapping values. So it will take two pointers and one temporary variable, and then we're going to swap their values. So, but the most important thing to remember here is to carefully choose the pivot and to use quicksort on bigger data sets. So it's not very good for the lower data sets. Let's enter 5 numbers. So it's really small data set, but it doesn't matter. Let's try something like 4 and 2. And here is my sorted array, so everything is okay. You can try to implement quicksort and the bubble sort. Then you can read from one file. You can store in one file a lot of big numbers, and then, for example, 10,000 of different numbers, and then you can compare the time that the bubble sort needs to sort that numbers and quicksort. So you will see a big difference. Let's jump on the problem number 23. Let's see. Explain the difference between malloc and calloc. So, okay, I will call both of these functions. They will allocate the memory on the heap. What's the main difference? Well, the number of input arguments. So malloc will take just one argument, but calloc will take two arguments. So uh, that's the main difference between these two functions. Also, the malloc should not initialize values of bytes inside of that block on the heap. But when I compile this program here, also do not always remember to free the memory on the heap. But when I compile this program, you will see right now that my memory in the allocated with malloc is also filled with zeros. Why? Well, that's the job of operating system, because that part of the memory previously maybe some other process used that memory in the heap, and for example stored the part of password or some important data, and operating system cannot let you to read that memory, and because of that it will fill your memory in the heap with zeros. So the main difference between malloc and calloc function is just in the number of input arguments. Okay, so let's jump on the problem 24. Let's see. Yeah, we should use recursion to find the sum of digits of entered number. You can use loops for this job, but it's better with it's maybe harder with recursion, and it's good for practice. Here I'm reading just a number, then I will call the function to get the sum of digits, and here's the actual algorithm. It's really simple. Now you're going to see that in action. I will enter 1, 2, 3, and I will get 6. You can enter something bigger, and it's worked. And right now, our last problem is problem 25.c. So write the program to find all prime numbers up to a given number. So we're going to have a range of numbers from 2 to n. So something like this, from 2 to n, including n, and we should find all and display all prime numbers in that range. Okay, so I will read my number n. Then my for loop will go from 2 up to the n, including n, and then I'm calling the function prime. It will return 1 if the number is prime, otherwise it will return 0. So if I'm here, that means that I is a prime number, and I will display I. Here is our actual our function. So how to I get some number here. I don't know which number, but how to know if that number is prime or not. Well, start from the 2 and go to the half of size of that number. So if here is 10, you will go from 2 to 5, increment for 1. And if you find that you can divide them, well, just return 0 and don't go further. It really doesn't, you don't have to go. It's through the end of that loop. When you find the first number that you can divide, well, just return 0 immediately. Otherwise, if you are here, then you didn't find any number from this range, and just return 1. Okay, let's compile that. Enter number, let's say 20, and you will see all the prime numbers in the range from 2 to 20. So here are the numbers. You can enter some bigger number, for example 10,000. Oh, I'm sorry. And we got our numbers here, a lot of numbers, so we don't have to read them all, but that's the idea behind this problem. So we finished our project. We solved 25 different programming problems for C job interviews. I hope you enjoyed this project. Follow education ecosystem. You can expect more great projects in the future. My name is Rečko Brogic. Wish you all the best, and bye.